Hello guys, today we are doing calculus, of which we are gonna be specific. Actually our first topic, first subtitle on calculus is average gradient. And as you can see here, for average gradient we only have this formula, of which it says y is equals to y2 minus y1 the whole divided by x2 minus x1. I cannot explain more about it, but I'm gonna do the example, of which I'm gonna show you how this formula works. Here in this example we have only we are given two questions, of which the first one says given y is equals to 5x squared minus 4. Then they say calculate the average gradient of a given function of which our function is y is equals to 5x squared minus 4. And they say this function, it is in between x is equals to -4 and x is equals to -1. Our first step to approach this question is to say y is equals to 5x squared minus 4. We are given this equation. They say we must calculate an average gradient. The first step is to say at x is equals to -4, our y is equals to 5x. 5, instead of x we are gonna substitute -4. Instead of x we are gonna substitute -4, of which is gonna be -4 minus 4. Then when you pass this to a calculator, it gives us 76. Then the second step, it says at x is equals to -1, our y is equals to 5. Again, instead of x we are going to substitute our x here, of which is -1 minus 4. Then -1 square is 1. 1 times 5 is 5. 5 minus 4 is 1. Then now we are calculating our average gradient, of which is gonna be equals to y2 minus y1 divided by x2 minus x1. Then we come to our solution. We are now looking for x1, x2 and y1, y2. Our x1 we will presume as this is our x1, this is our x2, and this is our y1, this is our y2. So when we come here, we will say our y2 is 1 minus our y1 is 76 divided by x2. Our x2 is -1 minus x1 is -4. Do not forget to put the bracket when you are substituting. Then now we simplify this. of which gonna give us negative 25. This is our gradient, our average gradient. Then now we are going to look for question number 2. That says, question 2, it says, calculate the average gradient of the curve f of x is equals to x into x plus 3 between x is equals to 5 and x is equals to 3. How are we going to approach this question? As we are given here, they are saying that our f of x lie between x is equals to 5 and x is equals to 3, of which this one is going to be our x1, x2. Now we need to calculate y1, y2 using this function. How are we going to calculate it? I'm going to come to number B. I'm going to first calculate our y1, y2. Number B, Roman figure number 1. I'm going to say we're given f of x is equals to x into x plus 3. The first step is to simplify this. Remember that f of x is equals to y. Therefore, we'll say y is equals to x plus 3. Then we simplify this. This x is going to multiply everything that is inside, of which x times x is x squared. X times 3 is plus 3x. Then from here we're going to calculate our y1, y2 using our given x1 and x2. Meaning we'll say at x is equals to 5, our y is equals to, instead of x we are going to substitute 5. We'll say 5 the whole square plus 3, 5. Then 5 squared plus 3, 5 is equals to 40. Then again add x is equals to 3. I'm going to calculate again y, which is, we are now substituting 3 instead of x, which is going to be 3 square plus 3. Then when we push these to our calculator, it's going to give us 18. Then now we write the general formula that says y is equals to y2 minus y1 divided by x2 minus x1. Then now we come again to our solution and look up for x1, x2, y1, y2. Here when we say x, we first started that our x is equals to 5, of which we're going to make this to be our x1. Then this is our y1. Again, this is our x2, this is our y2. So we are going to take this accordingly, then we substitute it on the given formula, of which is our general formula. y2 is 18 minus y1 is 40. Then we come to x2 is 3 minus x1 is 5. Then substitute these. When you subtract 8 minus 40 and 3 minus 5, then you divide it, it's gonna give us 11. And this is our average gradient for the second question, of which is our Roman figure 1. Then now we are looking for our Roman figure 2 that says, what can we deduce about the function f of x between x is equal to 5 and x is equal to 3? Our Roman figure 2, I'm going to write it here. We need to analyze this accordingly. What can you deduce? In order for you to approach this question, you need to look for the x values that you are given, of which our f of x lie between. The first one is x is equal to 5. The second one is x is equal to 3. Then you look up for each. After looking up for each, you look the sign of each one. Our x1 is positive 5 and our x2 is positive 3 again, of which we can conclude by saying we can deduce that f of x, because x1, actually our x values are positive. This means that f of x is increasing. Then you can write it here, because our given x values are positive, it means that our f of x is increasing. It's increasing, of which if these x values you are given and you don't know how to say it, how to deduce from the given function, you can also analyze it using a graph of saying, remember this is our x, this is our y. Then our x values x1 and x2. Our x2, where they say is 3, our x1 is 5. You can see that from this graph we are increasing. We are increasing. If you can calculate as we calculated, our y1, y2 is 18 and 14, of which 18 and 40. We are increasing, we are not decreasing. If we were decreasing, our x1 and x2 supposed to be negative. And again, our y1, y2 supposed to be negative 18, negative 40. But because our x values are positive, we can deduce by saying our f of x is increasing. Here is the proof. Thanks, I will proceed with the first principle. Okay guys, now we are proceeding from average gradient to the derivative of a function at a point. The first thing that you need to look when you consider the derivative of a function at a point, well, we need to look the basic of derivatives. The first one we have is this one that says the derivative from first principles, and the the derivative from first principle, we have a formula. This one is simple and straightforward. We just substitute from the formula. I'll show you how are you going to substitute from the formula. Our formula is f of x. If f of x prime x is equals to lim h approaches 0, f of x into x plus h minus f of x, the whole divided by h. And you must note that f of x prime x, what is it? f of x prime is equals to y prime is equals to dy over dx is equals to dx into f of x. These four functions, it is the same as f of x prime. Then we go to the rules of differentiation. In the rules of differentiation, we have 4 rules that we are going to consider. The first one, it says if f of x is equals to b, then f of x prime is equals to 0, meaning that we are going to consider b as our constant, and when we derive, in a differentiation, when you derive a constant, it becomes 0. Of which the second one is if f of x is equals to x to the power n, then f prime x is equals to n times x to the power n minus 1. How do we get this? We said we are having x to the power n. How do we get this? We're gonna look f of x equals to x to the power n minus to the power n. For a prime, we need to look. We're gonna take this n, multiply it here. Let us consider that is ax to the power n. When we derive this function, it's gonna be, we are going to take this n multiplied by a first, n x, then after multiplying n times a, you minus this n, you minus it by -1, of which is gonna be -1. You minus 1 from it. Then we will look on the third rule that says dy over dx is equals to, actually d over dx into f of x plus or minus g of x. This thing is equals to dy dx. This is gonna distribute, meaning dy over dx is gonna multiply f of x plus or minus dy over dx. D over dx is gonna multiply g of x. Here it is. It's gonna distribute. How we're going to distribute it? You said d over dx is equals to f of x plus or minus d over dx into g of x. Then the fourth one, it says given d over dx into k f of x, where our k is a constant. It can be 5, it can be 1, it can be 8, it can be 9. The only thing that we need to do is to take k out. How do we take k out? You just write it like this. Then you are left with f of x. Then you multiply d over dx with f of x. Then we're gonna get these. Then now I'm gonna do examples using these given rules here on the board. Do not go anywhere. Okay, now we are doing an example of a Actually, we are doing an example of a calculus where we are deriving a function from a first principle. And our formula, since I did talk about this, our formula is f prime x is equal to lim h approaches 0. F of x into x plus h minus f of x, the whole divided by h. We are doing example. Our example say that determine f prime x from first principle. Given f of x equals to negative 3x squared. The first thing that we need to do here is to take question 1 to decide solution. Then we take number 1, f of x is equal to, this is our first step. This is our first step. This one is our first step. We just write f of x is equal to the given function of which is negative 3x squared. Then the second step is f of x is f x plus h is equal to negative 3 x plus h square. And then remember, this f of x plus h, we have took this part from this formula, of which here we do have this. Now we are simplifying this so that we can substitute it on the formula accordingly. Let us first simplify this. Since we are having this, let us simplify this so that we can get variable of x and h. Then we are gonna say this x plus h the whole. Then when we distribute it, we multiply, simplify, of which is gonna be x times x is x squared, x times x is x squared, x times x times h is x, of which is gonna give us xh, h times x and h times h gonna give us plus h squared. From this step, we are adding and multiplying it by negative 3. X squared plus 2xh plus h squared. Then now we distribute negative 3, of which negative 3 times x squared is negative 3x squared. Negative 3 times 2 is negative 6hx. Negative 3 times 1 is negative 3h squared. Then now we are done with f of x plus h. We need to substitute it on the formula. How are we going to substitute it on the formula? Our formula, remember, our formula, this is our first step, this is our second step. Our third step is to write a formula. Formula f is equal to lim h approaches 0, f of x plus h minus f of x, then the whole divided by h. We do have f of x plus h, we do have f of x. We substitute it accordingly, equals to lim. We must note that I will be going with lim and h approaches 0. H approaches 0, then we substitute this. When we substitute this, it's gonna be negative 3x squared minus 6xh minus 3h squared. Do not forget to put bracket when you're substituting. Again, negative, then you put bracket. Our f of x is this one, of which is going to be negative 3x squared. Then the whole times divided by h. Then from there on, we simplify these accordingly. Accordingly. We're still going with lim h approaches 0. Lim h approaches 0. This one's going to be as it is, of which is going to be negative 3x squared minus 6xh minus 3h squared. This negative is going to multiply this negative, of which is going to give us plus 3x squared. Then we divide the whole by h. There's something that you need to note here. When you arrive in this step, after simplifying here, always when you arrive here, you need to cancel every variable or every coefficient that has x. Every coefficient that has x only. Of which here in this equation, we have negative 3x squared plus 3x squared. This one is going to cancel this. Now we are left with negative 6xh minus 3h squared. Every time you need to, actually every time when you arrive here, you need to cancel everything that has x. Then you leave everything that has xh or that has h. You don't just cancel, it's going to cancel automatically. Then we go to the next step. Our next step is going to be lim. It's going to be equals to lim h approaches 0. Then we say you are left with negative 6 hx minus 3h squared divided by h. Then when you arrive here again, you need to factor out h so that you can cancel this h, of which is our denominator. And yes, it's gonna be lim h approaches 0. When we factor out h, it's gonna be h negative 6x minus 3h. Since here we have h squared, we remove h to the other side and remove h to the other side. Here we are left with negative 6h. Here we are left with negative 3h. Then we divide by h, so that every time you need to end up cancelling this h, of which is our denominator, with the h that you will always factor it out. Then when we arrive here, we cancel h, we are left with lim h approaches 0 and negative 6x minus 3h. Then we need to note when you arrive here, after simplifying everything, factor out everything, you need to, when you arrive here, actually we are no longer going with this. Our chain of going with lim h approaches 0, and here after simplifying everything and factoring everything, meaning when we arrive here in this step, you just take this equation negative 6x minus 3h, but instead of h you put 0, of which is gonna be negative 6h minus 3, 0. And you also know that any number multiplied by 0 is 0, of which our answer is negative 6x. I'm done with the second question. And in order for you to prove that your answer is correct or not, you need to come to our given function, of which is our f of x, Then you write, we are gonna do this aside, not on your answer sheet or on your given answer sheet. We're gonna do this. I'm gonna say negative 3x. Then you differentiate this accordingly. Remember when we said the rules of differentiation, it says if we're given x to the power n, when we differentiate it's gonna be x prime s is equals to n. This n is gonna multiply here, of which is here we are having 1. Let us consider that we were having ax to the power n. This n is gonna multiply a, of which is gonna be an x. Then here we're gonna minus 1 from this n, of which is gonna be n minus 1. Then using this rule to this function, it's gonna be on this function, our a is negative 3, our n is 2. Then we multiply, we're gonna say f prime x. Then we multiply n times negative 3, of which is gonna give us negative 6. Then we write x again. Then you minus 1, of which is gonna give us 1. Then this is the same as this. This is our answer. To prove that really what we have been calculating is correct, you prove it using this rule. You must note always. Then now we are doing the second question. The second question says, this question, you need to note every time to this kind of question. The second question, again, it says determine f prime x from first principle. The question is always gonna be like this, from first principle. You need to note these words. This is the term, from first principle. You use this formula. Then the second question, it says given f of x is equal to 2 over x. 2 over x. I'm gonna come again using this formula, but our first step, remember our first step is to write f of x is equals to 2 over x. Then our second step is to write f of x plus h is equals to 2. Actually, instead of x we substitute this that is inside, of which is gonna be x plus h. Then we are done. We can't simplify this. We are done. We take straight from the equation, from the general formula of derivative from our first principle, of which is gonna be f of x, f prime x equals to lim h approaches 0, f of x plus h minus f of x divided by h. Then we have f of x, we have f of x plus h. We substitute it accordingly. Do not forget to put bracket when you are multiplying. Which we go with lim again. Lim h approaches 0. Our f of x, our f of x plus h is 2 over x plus h. You put bracket again, minus f of x is 2 over x. Again, you put bracket, the whole divided by h. Then from there on, from here, we're gonna use this rule that says, actually this rule of division. This rule say that if a over b this rule of addition. It says if A over B minus plus or minus B plus or minus C over D. We are gonna simplify this. How can you simplify this? We simplify it using this rule. A times D is A times D plus or minus B times C is B times C, the whole B times D. Or you can, or to simplify this, you can use, to simplify this, is either you use this method of saying A times D plus or minus B times C, the whole divided by B times D. Or you can use this method that says, actually this method of taking the highest common factor. The highest common factor is BD B times D, B times D. Again here our highest common factor is B times D. Then it's gonna be A times D minus plus B times C. It's the same thing, but for me I prefer that better use this one. But I use this one because this one is straight and it's simple and straightforward. A times D here plus or minus B times C here. Then the denominator is gonna B times D. We are gonna use this rule here, of which it's gonna be our second step, and our second step is gonna be lim over lim h approaches 0. Then here, since actually we simplify this again, it's gonna be 2 over x plus h minus 2 over b over x. Using this law again, I need you to relate. I said a over b plus or minus b over c, c over d is equals to a times d plus or minus b times c, the whole divide by b times d. We're going to use this rule to simplify our fraction here, of which is going to be our fraction. We're going to, from here we're going to say lim h approaching 0. Then we take as if our a relates to this equation. Our a is 2, our b is x plus h, our c is 2, our d is x again. We are going to say a times d, our a times 2 is x times 2 is 2x minus b times c, of which is our x plus h, the whole times 2, of which is going to be 2x plus h. Then we divide by b times d. Divide by b times d. B times c is b times d. It's going to be x into x plus h, the whole divided by h. Then taking this step to the other side so that you can further explain it. taking this step to this side, it's gonna be equals to lim h approaches 0, then 2x minus 2x plus h divided by x h plus h the whole divided by h. Then when we arrive here, we need to simplify this. How can we simplify this? We'll say lim h approaches 0. Here we have 2x, negative 2 times 2x. Here we have 2x, here we have negative 2 into x plus h. We need to simplify this first. The numerator is going to be 2x minus 2x. Negative 2 times x is negative 2x. Negative 2 times h is negative 2h. The whole divided by h into x plus h whole divided by h. Then when you arrive here, I said at first, I said at the first example that says when we arrive here, we need to cancel each and every coefficient that has x. Then we leave everything that has h or xh. But here we don't have xh, meaning we're going to cancel every coefficient that has x, meaning 2x minus 2x give us 0, we cancel it, we're left with negative 2x, of which is going to be lim h approaches 0, h approaches 0, we are left with negative 2h divided by x plus h, the whole h. Then from here, remember this rule that says a over b divided by c over d is equals to, actually this a over b is the same as a over b the whole c over d, and this one is the same as a over b times, since here we have c over d, when we multiply it's going to be, this is going to be a reciprocal of which is going to be d over c. This thing is the same as this one, is the same as this one. So here we're gonna apply the very same rule. You are going to apply the very same rule here using this method. But here, considering this equation says that we have negative 2x. Our negative 2x is a. Our x into x plus h is b. The whole divided by h, of which is our c, and our d is 1. Then we say we reciprocate this, meaning it's gonna be a over b times 1 over c. We're gonna do the very same thing here. How do we do it? It's gonna be, we're going to say lim h approaches 0. We said we're gonna reciprocate this, presume that this is over 1, then it's gonna be negative 2h over x into x plus h. This is our a, this is our b, then we multiply by our c. Our c is h, our t is 1, of which is going to be 1 over h. Then remember, in multiplication rule it says a over b times b over c, of which is going to be ab over BC. We're going to apply this rule again here. Again here. How do we apply it? When we say lim h approaches 0, our negative 2h is a, our x into x plus h is b, times d over c, of which our d and c is 1 and h. Then we multiply negative 2h times 1 is negative 2h, the whole, divided by x into x plus h multiplied by h. It's gonna be xh into x plus h. Then remember that we need to cancel h, our denominator, so that you can left with this. And now we are left with lim h approaches 0. We are left with negative 2 over x into x plus h. When we arrive here again, I said, when you arrive here, we don't know, actually this thing is no longer simplified. We can't simplify this. We're gonna take this thing again after simplifying everything, after dividing after cancelling the denominator of h. We are left with this thing, so we are gonna take it, and the more we take this equation, we are gonna leave this thing and substitute 0 when it actually 2. We are gonna substitute 0 when we get h. We're gonna take this, it's gonna be negative 2 over x into x. Where there is 0, we put where there is h, we put 0. Since h approaches 0, gonna be plus 0, of which when you simplify this, it's gonna be negative 2 over x squared. Again, we can prove this using this rule that says f of x equals to a x to the power n, of which our derivative of f of x equals to a n x to the power n minus 1. I'm going to do the very same thing here. Our equation is f of x is equals to 2 over x. This is the same as 2 to the power negative 1. Since it's the same as 2 to the power negative 1. And yes, remember, using this rule and this one, we're gonna say our a is 2, our n is negative 1. So we are gonna multiply our 2 with negative 1, of which is gonna be negative 2x, and we say it will minus our n with 1, of which is gonna be negative 1, then we get negative 2 over negative 2. Then from here we don't have to write our answer with a negative exponent. Always you need to note that we don't write our answer with a negative exponent. So to make our answer be simple and straightforward and have a positive exponent, it's gonna be negative 2. Take this 2 downside, it's gonna be x, and when you take x to be the denominator, your exponent changes to be positive. If it was positive, when you take it, it's gonna be negative. But here, our exponent is negative 2, of which now we have positive 2. When you make it the base to be the denominator, then now we are gonna proceed doing the example of rules of differentiation